treatment has been imposed, but you would identify what a treatment would be if it was an experiment. Okay. So in this example, we were interested in finding out, I guess, if somebody rode a bus. So we merely observed the data. I can't imagine what the treatment would be. We didn't require students to ride buses. We don't make students ride buses. If they want to drive themselves to school or they want to get a ride from somebody, that's up to them. So information about how many kids take the bus has to be in an observational study. It can't be an experiment. So what would be an experiment? Well, experiment would have to have a treatment. So if we see that it has a treatment, then we know that it's an experiment and we must identify it by name. Okay, so before we get to one of the experiments that the StatMedics site talked about review, I want to talk again about, this came up in a number of questions, the difference between explanatory and response, and when they ask you specifically about a confounding variable, how do I make sure I get all my points? So if you think about it, it's chronological. Would one thing explain another? So an explanatory variable came up, whether or not you smoked. Again, it is the word variable, so it has to be whether you did or did not smoke. Whether you did or did not smoke, okay? And then the example also said, well, would that help explain? Would that tell me whether or not you're more or less likely to get Alzheimer's? So my response variable was whether or not I had Alzheimer's. This was two pieces of information we collected. So do you smoke? Yes or no? Do you have Alzheimer's? Yes or no? Now, you might be thinking, what could be a confounding variable? So we talked about this. I just want to use a different color here. So does smoking explain whether I have Alzheimer's? That's the explanatory. That's my response, right? And what would be a confounding variable? A confounding variable means I have to talk about how it affects either one. So, let's say I put exercise here. Maybe people that exercise might not smoke, and maybe exercising helps ward off Alzheimer's. So notice that's how I came up with this confounding variable, because I explained a relationship with both the explanatory and the response variable. Now, back on the other example they used on the video, they said, would the type of review a student uses for AP Stats help explain the AP Stats score they used? Well, in the observational study, they merely asked, did you use the StatMedic review website or did you use a review book? So a lot of us like those Barron's review books, right? And this happened in his classes the previous year. They merely filled out the information after the fact. So this would have to be an observational study. There wasn't a treatment. The treatment would have been the type of review they used, but it wasn't imposed on them. And so that was an observational study. Now they identified what could have been a confounding variable. So notice the confounding variable would have to be, you have a sneaky suspicion it would influence both the explanatory and the response. So maybe, based on their observational study, they noticed that there was a much higher review passage rate when the students used the online versus the book. However, it could mean that students that are more motivated were likely to pick the online, and students that are more motivated were likely to get higher scores. So that's an example of student motivation. Okay, so now that we've talked about a lot of these vocab words, let's talk about what would it look like if we actually did an experimental design. And the reason we would want to is that if we do see a statistically significant enough difference, we can actually say causation. So did the online review cause a higher score? So notice the two scores that they collected. One was the review book of 3.8, and one was the StatMedic online of 4.3. So we could get causation if, in fact, we see that this is statistically significant enough of a difference. And this is how we would have to design the experiment. So if we took 100 stat students, we must do random assignment between the two, or we cannot make an inference, right? So we randomly assign half of the people in group 1, half the group in group 2, and we must assume these are roughly equivalent groups. We assign, so this is our treatment of the stat medic online, and the review book to the second group, and then we check their results after the exam. Now let's say you have a sneaky suspicion that that if it's separate, it could make a difference. So maybe we feel like the stat medic software is more useful to females, not so much for men. All right, if we think that, then before we do the experiment, we can separate. Now notice I didn't put random assignment here. And the reason is because I know you're a female, so I put you in this group. I know you're a male, so I put you in this group. Then I randomly assign you. So this stands for half of the 56, or 28, group 1 female, and the second group was randomly assigned group 2 female, right? And then this is male and female. So what would this mean? Well, in group 1, I'm going to give the Stat Medic Online review, and then this is the review book, Stat Medic Online review, and this is the review book. So now each man has an equal chance of getting either treatment, and each female has an equal chance of getting either treatment. And that way I can compare the results, and maybe this will keep from confounding things later. Okay. Now let's just wrap it up with these last few words that I think were important anyway. We've said now a couple of words multiple times. Block design is when you do grouping in an experiment, and in a stratified random sample is when you do grouping in an experimental study. Voluntary response is when you get stronger opinions, both good and bad, and those come when people choose to participate. You should also give a direction. So again, if you ended up getting a lot of people said positive things in a survey, but it was at a voluntary response, you can say, you know, they had to respond out loud, and so people are kind of embarrassed to be rude, right? Give a direction that because they were given an opportunity to decide to give feedback or not, and they had to give the feedback out loud, all the feedback was positive. What else? Well, cluster sample, as we pointed out, note that multiple data got pulled from each clump, right? And each clump had an equal chance of being selected. We said that. A control group, we haven't talked about that, but a control group is when one group is not given a treatment. And so therefore, an uncontrolled experiment is when you notice that there was no controlled group used. So I would call this one up top an uncontrolled because I actually don't have a control group where they didn't have any review at all. Now, what is the placebo effect? Well, technically that's when a subject responds favorably even without the treatment. So typically that would be with medicine. They think that they're getting a medication or the new medication, and it's really just the old medication, or it's really just a Tic Tac. It's not anything that provides any medical help at all. All right. A couple other things that kind of go together, right, is blinding. So subjects, that's when the subject doesn't know they're getting what they're getting. Double blind is when neither the subject nor the people interacting with them. So it doesn't have to be the people collecting the information, but the people interacting with them. So that's the second person that is blind. Also, it's important to mention that when you use volunteers, then you can only infer about those similar to the subjects in the study. You can only infer about the people similar to those people in the study. And the last one that came up was matched pair. That's when we have a block size of 2. And so we end up giving random assignment to each pair. So if you notice, one person, like you, got both ways. We did this when we used 2 different strategies for memory. You were your own matched pair, but each of you were randomly assigned one of the 2 strategies, and then you ended up doing the strategy you hadn't done yet. That was an example of a matched pair. Also in the book, this was in the bicycle, I believe, where both got to use the tire. So this is what's happening. The bicycle itself got to use both treatments because the front tire was one thing and the back tire was the other thing in random order. Thanks for joining us for Unit 3. Have a good one.